Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad HARITH bin Muhammad SUHAILI. My meeting number is 2211 867. So I will be doing the introduction for our web donation management system. Uh, it is, as the name suggests, a web-based donation management system that provides a simple and easy to use interface for stakeholders. So here we will have four main stakeholders, which are the administrator, the donor, the beneficiary, and the payment processor. The administrator will oversee all the donation process, like the uh, fund allocation and the notification of any ongoing donation. The donor will be the one that provide the income, the resources to the beneficiary, and the beneficiary will receive the fund from the administrator from the fund allocation thing. Then the payment processor will be the one that process the payment that the donor did to the system and send it to the system. Okay. So the second is the system requirement. So we have the functional requirement and the web based and the non-functional requirement. For functional requirement, we will have the user registration and login. For the user to make an account. Secondly, we have the donation management to manage all the money that the donor provides. The second is the third is the donor management. Here, the system will store all the relevant information about the donation and the donor personal information. The fourth one is the fund allocation. This is a system for the functional for the administrator to allocate the fund to the project that the beneficiary requested. And the next one is the reporting and analytic. This is especially for the administrator to analyze and planning for any further plan for the stakeholders. Then we have the communication tools. Here we will the stakeholders, the beneficiaries, and the donor will communicate with each other, like an update or any request. So we will have we will need a communication tool for this. Then we have the payment integrations to make the payment or the donation money experience to be smooth. And then we have the lastly we have the audit logging. So here we will the system will keep track all of the activities in the system, all the money where it goes, where it is being allocated uh, for logging purposes, for auditing purposes. So the next one we have the non-functional requirements. So here we will have the security, the performance, the scalability, the usability, and the reliability. For security, particularly we are following the ISO IEC 27001. This one is for, yeah, let me check. This one is for information security, and we have the PCI DSS for payment secure payment processing. So we will following these two module for better security for our system. Then we will try to make a better performance, scalability, usability, and reliability. So to make our system a smoother experience for the stakeholders. Okay, so the next one we have the use case diagram. So here we will for the overall system we will have like three subsystem. We have the account management subsystem, the donation process subsystem, and the create report subsystem. So here in the account management subsystem, we have the user, which consists of donor and beneficiaries. Then we have the administrator. In this case, will be the register account. The user will register account. If the account does not exist, the user will need to uh, right, here the user and administrator will log in account. If the account isn't created yet, then they will be prompted to register an account. After that, they can manage the account. For the administrator will manage the account for all for all the users. The user can update their profile, and both the user and the administrator will have the access to their respective history. But administrator can view all the user history. So this is the donation process system. So this is where all the donation, the money moving activity is done. So here we will have the dana. The dana will start a donation, will make a donation. Then it will be asked to confirm payment. Then the payment processor will try to confirm the payment made by the dana. If the payment done succeed, the donor will get a receipt. But if it fail, uh, uh, the system will handle the payment failure and try to ask the donor to retry the payment or something else. Then the donor will can update the record, like the record for their donations in their history update. Then the beneficiary can request a fund. Then administrator can view the fund and allocate the fund needed based on the request made by the beneficiary. Then if the allocated fund succeed, the beneficiary will get the receipt for the funding. Then after all of this has been done, we have the report system. So this is where the analytic and the report be activity being done. So beneficiary and administrator will generate a report. The report generated by administrator is the one that for analysis purposes, but for beneficiary, this is the one to update the fund usage to the system. So there is some sort of integrity for the beneficiary. Then we have the analyze trend. So the user will use the report to analyze the trending for further development for the system or the business entirely. Then the dana will send a communicate. Then the administrator will send a communication to update to the dana for the plan or any update for your donation. Then the basically will plan an outreach for the planning or for the planning of the business entity. Okay, so we will moving to the flowchart. Here we have to flowchart. And Burst flowchart is to illustrate how the user and the administrator view the system when they log in into the system. So we got this. For this one is for for the user. The user will log in here. If the account hasn't been created, then the user will need to register an account. But if the account is registered, then the user will manage to log in and enter the user dashboard. So here in the user dashboard, the user can view all the options available for the users. So we got the payment, we got the view history, update profile, and the logout here. But for the administrator, all is the same. But if an admin enter using the admin privilege account, the admin will have an additional admin privilege. The admin can edit another user. They can manage another user account, and they can also delete another user account. So this just a little bit difference. So yeah, this is the general flowchart for the how the admin and the user enter the system. So finally, we got the activity diagram. Here, this activity illustrate how the user will do the payment activities. So here, user the dana will log in into the system. If the account is already registered, then the dana will proceed to the next step. But if it is not, the dana will be prompted to register the account. And after it is done, the dana will move to the next step. to make a donation. So here the donor will be prompted to fill a donation form, like how much the amount of the donation, what project that the donor want to allocate the funding. So after all if it being done, the detail of the donation of the payment particularly will be sent to the payment processing. So the payment processing will process the payment, and if the payment successful, uh, the confirmation email will be sent to the user. But if it is failed, then the user will be prompted to retry the payment, maybe for some unknown reason, like uh, not enough balance or something like that. So after, let's say, the payment was successful, the system will send the payment processing will send a confirmation email to the system, to the user. Then the system will take the log, will take the all the activity information and keep track the all of the information in a log donation database. Then after that, it will generate a receipt for the users, and finally it will notify the admin of the donation that a donation has been done. Then the activity end here. So yeah, that's is the general workflow in the activity diagram to illustrate how the donation process work. So that's all for me. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amin. I will be explaining about our system architecture. So basically, KHAIR Connect is built using microservice architecture, which is basically a way of organizing the system into small independent service. Each service focuses on one specific function, like the user interface, donation processing, or reporting. Now, why did we choose this approach? First is scalability. With microservices, we can scale each part of the system separately. For example, during a big campaign, when donation traffic spike, we can scale up to the donation processing service without affecting the rest of the system. Second, resilience. If one service fails, let's say the user management system, it doesn't bring down everything else. That is especially important for critical feature like payment processing, which need to stay online no matter what. Third, it gives us flexibility in development. Different teams can work on different service at the same time. So while one team focuses on improving the donation experience, another can work on reporting, and no one gets in each other's way. Another great thing about microservice is technological diversity. A service can use tools, programming language, or database that are best for its job. We are not stuck with a one-size-fits-all approach. And finally, microservices make it easier to integrate third-party tools like payment gateways, communication APIs, or analytic platform, so we can enhance the system without a ton of extra work. Moving on, we have implemented a component-based design to reflect the modularity of the microservice approach. First, we have the user interface component, which handle all user interactions such as logging in, browsing campaign, and making donation. It communicates directly with the donation processing service to ensure a seamless experience. The donation processing component is central to the system. It manages payment transactions, integrates with secure payment gateways, and trigger email notification to confirm donation. Next, the donor management component tracks donor information, preference, and engagement history. This data is stored securely in the database and accessed as needed by other components like reporting. The reporting component generates real-time analytics and donation summaries. It provides critical insight for administrator through the admin dashboard. At the core, the database component ensures all data is stored securely and is accessible to components like donation processing, donor management, and reporting. Finally, the admin dashboard allows administrators to monitor the system, view donation report, and manage campaign effectively. As you can see, each component communicates through defined interface, ensuring modularity and independence. For instance, the user interface calls the donation processing service via APIs, and donation processing access the database for transaction record. This decoupled architecture ensures that if one service such as reporting require update or face downtime, it doesn't affect critical service like donation processing. Now let's talk about the tactic we are using to meet our non-functional or quality requirement. These are the things that ensure the system isn't just functional but also perform well. First up, performance. We are using load balancing to spread the request across multiple instances so no single server gets overwhelmed. On top of that, we optimize our database queries and added caching mechanism to make sure the system responds quickly even under heavy load. Next is scalability. Here we are relying on container orchestration tools like Kubernetes. This allows the system to automatically scale up or down based on the traffic we are experiencing. And because of our microservice design, we can scale specific part of the system horizontally. So if one service needs more resources, we can give it what it needs without impacting the rest. Moving on to security, this is our huge priority. We have enforced encryption for all communication to keep data safe and fully compliant with data protection regulation. Plus, all our APIs use token-based authentication, so only authorized users can access the system. For usability, we are designing with the user in mind. The interface will be intuitive and mobile responsive so it works seamlessly on any device. We are also including accessibility features like screen reader compatibility and high contrast mode to make sure everyone can use the platform comfortably. And finally, reliability. We have implemented health monitoring tools like Grafana to keep an eye on system uptime in case something does go wrong. We have got a failover mechanism in place using redundant server and database to keep the system running no matter what.
Assalamualaikum, my name is Ahmad Khairil. I'm in HISHAMUDDIN, metric number 2212947. So now I will talk about the detailed design of our web-based donation management system. So for the user interface component of our system, it can be represented using a class diagram like is shown in the slide. As you can see, there are 6 different components or classes which represent the subcomponents of the user interface component. We have the donation history, donation registration, campaign browser, donation form, receipt generator, and the user interface class itself. So each of the 5 different subcomponents are aggregates of the user interface class. As you can see, there are different relationship between the classes. The donation history and the donation registration has a dependency relationship, same as donation form and campaign browser, and also receipt generator, and also donation form. So there are several different attributes for each classes. For example, for the donation history class, we have the list of donation attribute. And also we have the fetch history method and also display history method. And for the campaign browser, we have a list of campaign and search query as the attributes, and also display campaign as the method. The design pattern that could be used in order to build this component are the factory method and also the observer pattern. Specifically for the factory method can be used for the receipt generator component. Next, we have the donation processing component, which also is represented using the class diagram. As you can see, there are 6 different classes. We have the donation processor class itself, and also donation repository, notification service, payment processor, payment gateway, and also donation validator. So the design pattern that could be used in order to build this component are the facade pattern and also the observer pattern. So for the facade pattern, the donation processor can act as a facade, simplifying the donation workflow for the rest of the system. For the database component of our system, there are 6 different attributes that should be represented in the database. So in an SQL database, this would be the tables, or in the NoSQL database, it will be the documents or the collections. So first we have the donor. We also have campaign, donation, receipt, admin, and also report. So the donor has a relationship with donation, which the donor has many donations. The campaign has a relationship with the donations also the same, and also the donations belongs to a donor and also a campaign, and a receipt is a link to a donation, and also an admin manages campaign and also generate reports, and for the reports the relationship is generated by admin. So here we have a prototype for the donation processing component. So first we need to create this different subsystem or the subcomponents of the module. So first we have the user management, or in our case the donor management, and we also have the payment processing, the receipt generation, and also the database subsystem. This is for handling database operations. Each of these subsystems are represented using a public class in the Java language. Next, we have the donation processor class. The donation processor class acts as a facade, simplifying the interaction with the different subsystems. So this is how the donation processor facade class is implemented in a program. First, you need to create a new donation processor object, and then you can call the process donation method and pass the different required attributes to the method, and then you can do it multiple times. So this is the output of the prototype. As you can see, the first line is the validating donor. So from this log, we can see that the system is validating the donor, and you can also see the system is processing a payment with a specified amount and using a specific payment method. And then we can see the system is having donation to the database, and then generating notification, and also it specifies what the notification says. And also this can be done multiple times. Next, we have another prototype for the receipt generator subcomponent. So for this component, we will use a abstract factory method. First, we need to specify the interface for the receipt. Okay, next, we need to implement the specific receipt types. For example, we have the PDF receipts, and this class will implement the receipt interface. And we also have HTML receipt and also email receipt. So next we have the factory method for our component. So the receipt factory class will provide a method to create the specific receipt types, for example, the PDF, HTML, or email receipt types. Next, here we have a basic template of a donation data class. This is a helper class which represents the donation details. So after all that, we need to create a receipt processor class which will use the factory method inside its process receipt method. So in order to implement this factory method in the main class, first we need to create a template donation data and example data, and then we need to create a processor object, a receipt processor object, which will call the factory method, and then we can call the process receipt method inside the receipt processor object. So the output of the prototype will look like this. As you can see in the output, the system is generating a PDF receipt content, and then we can see the system is saving the PDF receipt to a certain folder. And this is done 3 times using different receipt types, the PDF, HTML, and also email receipt.